Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving the last problem of our 30 LeetCode challenge, and the problem that has been given to us today is check if a string is a valid sequence from root to leaves path in a binary tree. If you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below. And let's just jump right in. So problem description is that given a binary tree where each path going from root to any leaf form a valid sequence, and you need to check if a given string is a valid sequence in such a binary tree. So we get the given string from a concatenation of an array of integers ARR, and the concatenation of all the values of the nodes along a path results in a sequence in the given binary tree. So in simpler terms, you've been given the binary tree and you've given a target array, and you need to find out whether this target array forms a path or a path from your root to your leaf. So as you can see over here that you've been given an example where you have 0, 1, 0, 1, and you can see that the values which have been highlighted in green form a valid path. But I just want to help you understand that if you've been given a target array as 0, 1, even though this path exists, it's not going to be a valid sequence because you need to go from your root to your leaf. So if you eventually reach your leaf, well, that would be your exit condition, and that would help you understand that, hey, we have a valid sequence over here. Other alternatives or other valid sequences for this particular tree would be 0, 1, 1, 0 and 0, 0, 0. So you can see if you have 0, 1, 1, 0, you can go from 0, 1, 1, 0 or 0, which basically helps you understand that you essentially need to go to the leaf. Cool. So another few more examples which have been given over here. You can pause this video and check them out. But let's just get started. So we have a few breakaway conditions or exit conditions, and our exit conditions are going to be if if we have, well, no node which has been given to us, then obviously that's going to be invalid for us. The second condition is going to be if we already have an element inside our array, we need to check whether that element matches with the present node. If it doesn't, that's also false. And the last and the most important thing is if we are on a leaf and whether the array that we have is almost identical to whatever node value that we have, well, in that case, we know for a fact that we can break out of this condition as well. So keeping these things in mind, we're just going to code away our logic, and there are multiple ways of solving this problem. You can also use extra space if you want, and basically create all paths from your root to your leaf, and then basically compare the lists. But we're going to be using recursion, and we're going to try solving this in recursion just to make this a little bit more difficult. So let's just start with the base condition. So the base condition is just going to be, hey, if nothing has been given to us, then we return a false. As you know, I usually providing inner functions, but this is valid sequence function can also be used in your recursion, and you can sort of code out your logic over there as well if you want. I want to make a quick function. I'm going to call it is leaf, which can help me understand whether the present node that I'm on is a leaf or not. So a leaf's definition is just going to be if your left and your right are basically none, well, in that case, that's a leaf. So that's one function that we're going to be using just to make our code a little bit more cleaner. And then we're going to have a utility function which is just going to take the node and the array which has been provided, and it's just going to perform operations on it. Eventually what we're going to do is we're going to return the output which we get from this utility function. So let's just pass in root and let's pass in array. Now we're passing in the root and we're passing in the array, the target array which has been given to us. So let's just talk about a few exit conditions which should be pretty intuitive. So the first condition would be that if the array does not really exist and the node exists, well, in that case we want to return a false. So keeping this thing in mind, we can also say that if there is nothing inside your node, then in that case you would also want to return a false. So I'm just going to pass in an OR over here. So you have either this condition or this condition. If either of them satisfy, you return a false. Pretty straightforward. Then the other condition that we want to take care of is that if our first element inside our array is not equal to the value which has been given in this present node that we are going to be iterating on, if that's not the case, then we return a false as well. So basically, if you think about this thing as the root, If your first element inside your array does not match the root value, well, in that case, you need to return a false because there cannot be any path that you can formulate using an array which does not have the same element as the root, as its first element. So keeping that in mind, we can sort of move forward and we can have one more condition over here, which can be our most important condition, which is the true condition, which will help us dictate whether we have reached our leaf and the array is equal to the node. So basically, we can say that um, if the first element inside our array, or in better terms, if we just say that, whoops, if we say that array is equal to the list of node.val, so this is basically saying that whatever array that you have presently is going to be equal to the node, um, and this is the list representation to manage lengths and all that stuff. If this is the case, and our node that we're presently on is a leaf, so we're just going to use this isLeaf function. So if these two conditions are satisfied, then we can return a true as well. The reason for this thing is because we are saying that if the present array that we have and the node value that we have over here are basically identical, well, in that case, you just want to return a true. So a simple example over here would be if you have a simple binary tree which just has one root, which is also the leaf. Let's just say one node, which is 1, and you're passing in 1. Basically, this condition would be satisfied in that case. So keeping those things in mind, you can see the way that we're progressing is that we're making assumptions that we're going to be updating this array and the node as we sort of going to, traverse through. So let's just quickly do that. So the idea behind using arrays would be that we're going to splice out the array as we're moving forward, and since we're going to be splicing it out, that's going to make a new copy, and we won't have to really worry about making changes inside the same array. You could also use an index over here as a parameter and sort of use that. That might be a little bit more cleaner for you guys, but I find this approach much more better. So basically, you just want to pass in, you want to recurse through your utility function, which we've given over here, and traverse through your node.left, and also traverse through the first element inside your node. So the reason why we're traversing through that is because we've already taken care of this condition, which says that if we already know that the first element inside the array and the node element are basically identical. If they were not, this would have returned a false. Otherwise, we're coming over here. So basically, we can say that if node.left array is place of 1 or util of node.right array is place of 1 as well, if either one of them sort of return a true, then you return a true. Otherwise, you return a false. And the basic intuition behind this thing is that you're traversing through you're recursively calling your util function, and you're assuming that essentially either this value is going to be returned, or this line is going to be called inside these recursion stacks, or either one of these are going to be called. And if you ever get a true, well, that would state that you have ideally found a sequence which is exactly the same. So let's just go ahead and run this problem, and hopefully this should run fine. So again, if you did not understand like what's happening over here, basically the traversal is going from your left to right, and while you're traversing, you're also splicing the array. In Python, you pass for reference, so the reason why we're not just passing in the entire array is just because we can take care of this thing. You can also pass in another index value over here so that you can take care of which index you're presently on and check whether that index is equivalent to whatever you have. That would also work. But this way, I just find it a lot more easier for me to understand that it's a lot more easier for me to debug the values of the array that I'm presently at and the node value that I'm presently at as well. So let's just go ahead and submit this solution, and hopefully this should be accepted. And you can see that this submission has been accepted, and that was basically it. Cool. So there are multiple ways of solving this problem. It really depends on which method you're actually really comfortable with. Most people already know the algorithm of computing paths from root to your leaves. So you can do that. That also works. And comparison between arrays is going to be much more quicker. But the only issue with that thing is it might be running at a complexity of O(n) squared. So that's something that you want to be aware of. Over here, we can also talk about that the time complexity that we're presently using is going to be O of n, and the space complexity is also going to be O of n as well. Reason for that is just because you might be splicing out the values, or it could be what is the maximum between the height of the tree versus the length of the array. So that would be your space complexity. Cool. So that was it for today's video. If you had any comments or there's something you didn't understand, do leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here and we would love to have you on board with us. This was the last problem of our April 30 LeetCode challenge. I'm still contemplating whether we should do the 31-day LeetCode challenge for me. So do leave it in the comment section if you want me to solve those problems as well. And I'll see you guys in the next video. If you've already subscribed, you're awesome. We all know it. And have an awesome day. Thank you.